Here are some examples from the day 41 assignment. Here we'll be simplifying radical expressions. They want us to simplify this expression and assume that all variables are positive. Exponents in simplified form should all be positive. Also, it's not mentioned in this problem, but if you are left with a rational exponent, an exponent that's a fraction, you should always leave it in simplest radical form. You should convert it to a radical if we need to. So here, the first thing I want to do is use my properties of exponents, and I know that if I have a power of a power, that I'm allowed to multiply those powers. So negative 2 over 3 times 3 over 4, the 3's cancel, and negative 2 over 4 is negative 1/2. So I have 1 over 36 to the negative 1/2 power. And between those two, I need to simplify the negative, and I need to simplify the fact that I have a rational exponent. The negative takes precedence. So the way that you simplify a negative power is that you flip the base. Well, you take the reciprocal of the base. So the base is 1 over 36, so that will now turn into 36, instead of 1 over 36, 36 over 1 to the 1/2 power. Now I can take care of the rational exponent by making that into a radical. A 1/2 power is the same as a square root, okay, because the index is the denominator. The 1 stays with the 36. 36 to the first is 36. So square root of 36 is 6. Simplify this expression. Assume that all variables are positive. Exponents in simplified form should all be positive. Okay, so here I have a fraction, and on the bottom of that fraction, I'm taking a base to a power. Now, on any fraction, the division should come last, so I need to simplify that denominator first. Since exponents are distributable over multiplication, I'm allowed to take this exponent to each term, and when I take a power of a power, I multiply the power. So I still have the 3xy on top. The x is 1 over 5 times 5 over 2 is going to be 1/2. And then for the y's, 2 over 5 times 5 over 2 is just 1. Now, I can try to simplify that rational exponent, that 1/2 power, and turn it into a radical. But actually, what I prefer to do, since I do have an x on the top, is I'm going to use the properties of exponents that tell me that when I'm dividing a common base, I'm allowed to subtract the powers. So this x has a 1 as an exponent, the y has a 1. So for the x's, 1 minus 1/2 is 1/2. And since the 1 is bigger and it's on top, I'm going to write my x to the 1/2 in the numerator. So 3x to the 1/2 so far is in the numerator. The y's are going to cancel out. 1 minus 1 is 0. They're gone, so I have no y's. There's no reason now to have a denominator, so I have 3x to the 1/2. Now, I'm not sure what because I have experience with this book before. This book might expect you to write it this way, but the way it should be written, because you should never leave a rational exponent, is to change that back to a radical. So I'm going to first try to write 3 square root of x. X to the 1/2 power is the same thing as saying square root of x. I'll try writing it that way first, and if they don't take it, then I'll put it back as 3x to the 1/2. But you should never leave a rational exponent. Oops, wrong one. 3 square root of x. Yeah, I had a feeling they'd mark that wrong, so let's try that, leaving it as 3x to the 1/2. 3x power 1 over 2 Yeah. If this were a test or a quiz, I would expect you. That's simplest radical form, not with the rational exponent. But I don't control the book, so just put it that way so you can get it right. Okay, simplify the expression by writing it using rational exponents and then using the properties of rational exponents. Assume that all variables are positive. So here I'm dividing an eighth root by a sixth root, which you're not able to do because you have to make the indexes the same. So the way that we can make them the same is to turn them to a rational exponent. I'm going to get this division here, the fraction, and turn it into a standard division sign. And I'll write my numerator out in front. There's going to be 6 to the negative 4 over 8. And then the second one's going to be 6 to the negative 9 over 6. Numerator over, it's the exponent over the index. Numerator over denominator. When I divide a common base, I'm allowed to subtract the exponent. So this is the same thing as saying just 6 to the negative 4 over 8 minus negative 9 over 6. So that's going to become plus 9 over 6. It's going to be minus a negative. So I need an LCD. The LCD of 8 and 6 is going to be 24. So 6 to the negative 12 over 24 plus, this is going to be times 4, so 36 over 24. Negative 12 plus 36 is going to be 24, so I have 24 over 24, which is just 1. 6 to the first is just 6. Okay, simplify using rational exponents. Assume that all variables are positive. Exponents in simplified form should be positive. Okay, so if we were to get rid of these radicals, that radical could be distributed over multiplication. So I would have x to the 4 over 4, y to the 6 over 4, and this times right here shouldn't even be there. I mean, that looks ugly as an x, but that does mean times. And they want us to go times an extra x to the 6 over 2. Because when you don't see the index here, that index there is 2. And that's going to be over y. Well, for the x's, 4 divided by 4 is 1. For the y's, I'm allowed to subtract 6 over 4 minus, if this y here is to the first power, that's going to be the same as 4 over 4. 6 over 4 minus 4 over 4 is 2 over 4, and 2 over 4 is 1/2. And then this x at the end, 6 divided by 2 is x to the third. So x times x to the third is x to the fourth, and then y to the 1/2. Really, the way that this should be written if this were a quiz would be x to the fourth square root of y. But from experience from the last one, I think they want us to write it as a rational exponent, but I wouldn't do that under normal circumstances. Simplify the expression using the properties of nth roots. Assume that all variables are positive and rationalize any irrational denominators, okay? Well, radicals are distributable over multiplications. So there's the same thing as taking the fourth root of 1296 the 4th root of x to the 6th, and the 4th root of y to the 8th. So let's see if 1296, if you can take the 4th root of it. 4th root of 1296, that gives me 6, so we're okay there. Let's just write this out. 1296 times x to the 6 over 4 times y to the 8 over 4. So 4th root of 1296 is 6. This is the same thing as saying times x to the 3 over 2, if I reduce it, times y squared. Because this x is the only one that still has a rational exponent, that's going to have to be rewritten as a radical. So I have 6y squared on the outside. Then I'm going to have a square root of x to the 3rd. But that x to the 3rd, I still have enough x's that can come out. I can bring out an x, so that's going to be 6xy squared. And on the inside is still an x. If you want to see y, by now I would hope you know this is not the first time we deal with radicals, but this is the same thing as saying square root of x. So I can bring out an x, and then one x stays behind. So 6xy squared square root of x. Okay, simplify this expression using the property of nth roots and assume that all variables are positive. So here we have square roots. For some reason they decided to write that it's a square root. Doesn't really make sense to me, but okay. Because they're both square roots, we can actually go ahead and subtract the exponents now inside of the roots. So for the x's, 7 minus 3 is 4, and the bigger exponent's on top, so that'll go up there. And for the y's, 3 minus 1 is 2. So we're gonna end up getting just the square root of x to the 4th and y squared. There's nothing left on the bottom because the bigger exponents were already on the top. I don't have to write the 2 as an index. So for the x's, I don't really expect you to write it like this anymore, but just if it still helps you to see it, okay. There's 2 x's that can come out and a y that comes out. There's going to be nothing left on the inside, so I just have x squared y. If you would have written it more formally, this would have been x to the 4 over 2 times y to the 2 over 2, which would still give you x squared y.